In this session, we are going to talk about data structures. What do we mean by data structure? There are two parts to this. The first part is data. So by data, we are simply talking about a value or set of values of different types, which is called data types like string, integer, char for character, or float, or boolean, etc. By structure, we mean the way of organizing information so that it is easier to use or it is usable in any way at all. So combined, we have data structure, which is a way of organizing our data in such a way so that the data is easier to use. The organization of our data is very important. Any organization for collection of records can be searched, processed in any order, or modified. Different kinds of data structures are suited to different kinds of applications. The choice of data structure and algorithm can make the difference between a program running in a few seconds or taking very long, like many days, to complete running. So these two things are very important when it comes to efficiency of our programs. Number one, the data structure that we use, and number two, the choice of algorithms. So how do we know which data structure or algorithm is best? We have to consider a few things. First of all, we need to make sure that our program meets the requirements. It also has to perform very well. Also, it needs to have low RAM footprint. And also, it needs to be easy enough to implement. These are some common data structures that you would have come across and we will discuss further in this course. Data structures like array, stack, queue, linked list, tree, heap, hash table, and priority queues. Before we jump to data structures though, what are data types? A data type of a value or object is an attribute that tells what kind of data that value or object can have and a set of operations that act on those objects. For example, a simple primitive int data type, right? It would have values within it such as 0, 1, 2, 3, negative 10, right? So these negative, positive integer values. The data type is int or integer. The values or examples of values are 0, 1, 2. And the operations that would be allowed on these values would be addition, subtraction, multiplication, dividing them, or getting the remainder or modulus. Right? So different data types have different sets of operations that are allowed to act on them. We can categorize data types in various categories. For example, we can have primitive data types. Primitive data types are sort of concrete representations of your data in the memory of the computer. So for example, int. When you have an int variable or int data type, you know that there is one number, positive or negative, that is held in memory that represents that variable or that value, right? Or if you declare a float variable, you know there's one float variable that is in the memory. So that is why I'm saying that that is like a concrete representation of the data that you're trying to represent. So that is primitive data types. You have about 7 or 8 depending on how you see it. These include int, float, double, boolean, character. You also have short, long, byte. Okay, so those are the primitive data types. You also have in Java primitive wrapper classes, and I will mention where this is used or when we use these. So these are again primitive because they are integers, floats, double, boolean, char, and byte, long, short, just as the primitive data types here. But you will notice that they are all beginning with capital letters, right? And that means they are the wrapper classes. Yeah, I will mention in a while when and where we use them. Anyway, we also have built-in classes or built-in helper classes in Java, and again I will mention that as we see some code. Then we have user-defined data types or UDT, so we can use classes to create our user-defined data types. For example, if we want to have a data type of an employee, we want to have lots of employees and the employees will have various attributes. So we can create a data type employee. For that, we would create a class called employee and so on. We will get to that. Sometimes we want to represent data in a way so that it's much easier for the programmer or for the designer of the program, right? It's from the user's point of view. For example, as I mentioned, the employee data type. The computer does not know, employee data type. It knows it can work with integers, it can work with Boolean, it can work with characters even, right? So if we want to hold some employee data in there, we have to define this data type, right? So we have an abstract idea, a concept of an employee. Then we use the primitive data types to create our user defined data type. So we can say that the primitive data types are sort of the building blocks that can be used to make abstract or concepts of user defined data types. And so there are some, apart from these classes here, there are others. For example, arrays. Array is not one, one block of, in the memory, one block of information. No, array is a concept, right? And we can think of that concept as the designers. So from our point of view, we can understand what an array is, and then we can use the primitive data types to somehow create that the idea of an array. And similar to that, we have linked lists, or we have these other data structures that I've mentioned, like heap, trees, queue, stack, and so on. This script I have added on our Moodle page, and you can try to run it to refresh your memory about programming. And also, if you want to take a quick look at simple syntax in Java. So for example, let's see how we work with primitive data types in Java. To create a variable that is of type byte, which is a primitive data type, you just use the keyword byte, right? And then the name is my byte num, and the value assigned to it is 100. That's an example. Another example of a primitive data type is int, right? So a normal integer, the value is given here, and the name is my num. Another primitive data type in Java is long. Another one is float, double, Boolean, and char for character. And then we have some non-primitives like string. So string is not a primitive data type, but there are built-in methods that allow us to use strings as if they are sort of almost like primitive data types, right? So we can say string, my string, or whatever name, and then hello world. And then to print it, we can do system out println my string. Then we have other non-primitives like arrays. By the way, this is a comment, right? So in Java, we use the // for comments. Anyway, so an array, we know as people what we mean by array. We want to have some elements within this, sort of like a list, right? And so to do that, we say we want to create a string array called my cars. And then here we have the values that go inside, or the elements that go inside. And if we want to access all the elements inside the array, we have to use a for loop. So that's a one-dimensional array. Then down here we have a two-dimensional array, and you can make whatever multi-dimensional array you want. So here, a multi-dimensional array of integers. So all the elements inside that array are integers. And in order to access the elements, we have to use a nested for loop. Okay, then we have some predefined, or a class called array list, and there are others like linked list and hash map, and another one is hash set. So these are some non-primitive data types that we have available in Java, and if we want to use them, if I want to create an array list, I have to import the array list class, and I have done that up here. Right, so this is how you would import the array list class if you want to use array list. And to create an array list, I would do something like this. array list called cars, and the elements inside the array list are going to be strings, right? So, and then we say array list string cars equals new array list with strings. So here we have the name of the array list. So cars.add, add a Volvo to it. Cars.add BMW, cars.add Ford. So you can use the .add method to add new elements to the array list. And if you want to print out the elements, instead of using the for loops or nested for loops and so on, you just have to pass the name of the array list, and the print line function there, or print line method, knows how to print out all the elements of that array list, right? So the advantage of using these classes is that in Java, methods or useful methods are already in there for use. Like you can set the value for it, or you can remove elements from it, or you can clear elements from it, and there are other helper methods that are available. Now here, note that the elements can only be objects. So for example, here you cannot have primitives as elements of these array lists. So string is not a primitive, so that's fine. If you want to have an array list of integers, you will not put small int. Instead, you will put the wrapper class, which is capital INT, so integer, or capital boolean, capital B, as I mentioned earlier. Okay, so that's where wrapper classes come in, wrapper classes for primitives. And then in a similar way, we use linked lists. Make sure you import. Similar way, we have hash map. So hash map in Java is like a dictionary. So instead of passing just one data type here, we will pass two things. So this is representing string for the first element here and string for the second element. What this means is the first one is a key and the second one is the value. So for the key England, the value is London, for example. I guess this is talking about capital cities. So capital city for England is London, for Germany is Berlin, for Norway is Oslo, and so on. And we have the method here called put. Right, so these different classes have their different methods, and they all are very useful depending on the application that we are working on. Right, so data structures with Java, I just showed you some of them. Arrays, single or multi-dimensional, you would declare it like this. So here, this line of code is telling us that we have an array called A, and it is holding elements that are all strings, right? And the size would be given here. Now that's with Java. MATLAB is another popular language, programming language. It does not have any specific data types. You can easily create an array or matrix just by specifying the values like this. So instead of telling MATLAB that you are creating a matrix of numbers or integers, you don't have to give the data type. You just say A equals so and so, and it creates that matrix. There are other languages like Python where you don't have to give the specific data types. How would you add two vectors in MATLAB? So if you have a vector called A and a vector called B in MATLAB, to add the two vectors in MATLAB, all you do is C or a new vector equals A plus B, and it will automatically add the elements in there for you. Whereas if you have to add the elements of two vectors in Java, you will have to do everything yourself. You will have to write code which would say, okay, fetch the first element of A, add it to the first element of B, store it as the first element of C. Then get the second element of A and the second element of B, add them together, store them, and store the total as the second element of C. And I would have to add the third element and then the fourth element. Okay, so there are advantages and disadvantages to both of these cases. And it just depends on what you want your program to do. Right, linked list and array list in Java. So as I said, Java has a rich set of built-in data structures like the linked list and the array list. You have the helper methods that are available. So here is a question. What is the difference between linked list and array list then? You find that out and write your answers in the discussion forum. I will go and check if you guys have added any of your answers in there. Okay, make sure you add in your answers into this discussion forum, and we can all discuss there. Also, I hope you have set up your your Java in your computers so you can do the Java programming. I have added a link here, which is a nice, a decent video to follow. As for It's actually for Microsoft Windows 10, but you can easily find lots of resources online. Just check on YouTube if you're using Mac OS or Linux or in anything or any other version of Windows. You can easily find videos that guide you on how to set up the Java development kit on your system. Okay. Once you have set it up, make sure you test it out by trying some of these programs. Right. So, for example, I have added this test Java file with basic syntax. What you can do is save that. Right, so please save this file. For example, javabasics.java, that is the file. Let's say I will save it on my desktop. Okay, if I save it on my desktop, there, I know what it is called. So open it, showing folder so that I can click here and I can see where it is located, right? So it is in my desktop folder. Then if I want to run it, I can run it in an IDE, right? So you will need to set up your own IDE. I use Eclipse. I also use NetBeans. You can try out other ones. It is completely up to you. You will have to explore a bit and then find which IDE you want to work with. But if you're not working with any IDE and you have just used text, what is this, text editor like Notepad++, you could even write your code in there, right? Even if you, wherever you write it, for example, this one, you just save it. It's already written, just save it. Know where you have saved it. I know it's on my desktop. Then I will open up my CMD. So press start and CMD. Okay, that's my command prompt. In there, I know where it is. It is on my desktop. So I will then do CD okay, so I get into my desktop and then I have to first of all compile it. So using the Java compiler, I know it is called the what is it, Java Basics. So Java Basics dot Java is the file, and the command to compile it is Java C. Enter. Okay, now it is compiling it, and it has compiled it. Now I can run it. So to run the file, I say, instead of Java C, I just say Java and then Java Basics. Okay, so that ran that program for me, and the program actually didn't do anything useful. It was just creating those variables, if you can recall. It was just creating those variables and then printing them out, right? These were the what were they? The array list, the linked list, and the hash map and the hash set, right? So you can try it out that way. Please experiment and see how you like to do your programming. Get used to it, because we will be doing a lot of programming, especially for your labs and your assignments. Okay, so that is all for this session. We will continue in the next recording.